Okay, the first question over here. The diagram shows electronic structures of atoms P and Q. P is over here, it is having just one electron in the only orbit that is there. Q is over here. Okay, just see how many electrons are there in the outermost shell. Okay, this is 1, 2, 3 and 4. Okay, so the 4 electrons are there in the outermost shell for Q, and P is having just one electron. P and Q combine to form a molecule. What is the formula of this molecule? Okay, now if you look at P, its electronic configuration of P is 1 because there is only one electron. In Q, in the outermost shell, there are 4 electrons. Okay, so if I write down the electronic configurations first, how to obtain the formula of the compound? This is what we are doing. Okay, P is there. Its electronic configuration is only 1. That's the only one electron that is there in the outermost shell. Okay, and Q that is there. Okay, it's having 4 electrons in its outermost shell. So Q is there. Okay, first orbit is 2, second orbit is 8, third orbit is having 4 electrons. Okay, this is the electronic configuration for Q. Now in the outermost orbit here there are 4 electrons. Here in the outermost orbit there is only 1 electron. Remember, in the first orbit there can be only 2 electrons, so one more electron is needed. So the valency of P is going to be 1 because one more electron is required. Q is having 4 electrons in its outermost shell, so the valency of Q is going to be 4. Now how do we write the formula of the compound? We simply have to exchange these valencies. These 4 will come over here, this 1 is going to come over here, so the formula of the compound is going to be P4Q. Okay, so you can just have a look at all the options that are over here. Okay, P4Q is this option whose formula we have obtained. So the correct option over here is going to be this one. Yes, if anybody is having any questions, you can ask. I have unmuted everybody.
Copy this. No, no. Or
Yes.
do we have to copy this?
No. Just pay attention because the class is also getting recorded. If you have any questions, then you can ask me as we have completed the question. Second question. Don't discuss amongst each other. Just pay attention here. See the second question. 2 isotopes of helium are He32 and He42. Which 2 diagrams show the arrangement of particles in these 2 isotopes? I have just done this yesterday. The definition of isotopes. Isotopes are atoms of the same element which have same number of protons but they have different number of neutrons. Okay, and how many protons, electrons, neutrons are there, that is also given over here. That is the key. Okay, so these are the 4 options that are with us. There will be 2 protons in the nucleus, and of course for both the isotopes there will be 2 protons and the number of neutron is going to be different.
C1.
So the D1.
Okay, you can see here I have just said the definition of isotopes. They have same number of protons, they have different number of neutrons. Now here,
C1.
okay, you can see over here in C part, there are two protons, two protons. Here there is one neutron, here there are two neutrons, and of course the number of electrons are also same. Okay,
So
so
the
the correct
answer is the
option,
C1 and C1.
yes, the correct option over here is going to be C. This is going to be the, these are going to be the isotopes. Both of these will be isotopes of helium. Okay, now this number, that 3 that is representing on the top as a superscript, that is the sum of number of protons and neutrons, which is the atomic mass number. So 2 plus 1 over here, this 3 that is represented here as superscript, that is its atomic mass number. Same way for the second atom, 2 protons plus 2 neutrons, you can see the number that is written over here as superscript, that is 2 protons plus 2 neutrons, atomic mass number is 4. Both of them
Sir,
atomic number is 2. So that is number of protons. Yes. What's your question?
I was asking that only.
Alright. Let's move ahead to the next question. Question number 3. Okay. Two elements represented by, okay, this is a white blank circle and a dark circle form a compound. Which diagram shows the molecule of the compound? Okay.
So can I
Yeah, you can try.
C C1?
Okay. The third option, that is C. See, the reason for that is they are forming a compound. Now here the atoms only are separate, there is no bonding between them. Here there is only molecules, there are only molecules of B. There is no no first kind of molecule. Here in C, you can see both of these are different kind of atoms bonded together. So this is going to be a compound from these two kind of atoms. Here you can see, okay, the black bonds, that the black kind of particle which is there, it's not bonded with the white kind of particles. So here it is simply going to be mixture of these two kind of molecules. In case of A, it is going to be the mixture of these two kind of atoms, because here even these both are not bonded, even these both are not bonded. Here you can see these both are bonded, so it is going to be molecule of second kind, this is going to be the molecule of first kind, but these both are not bonded, therefore this is not a compound. So the correct option over here is C. Anyone is having any questions? I have unmuted everyone. If anybody is having any doubt or any questions, they can ask me.
So
Yeah.
sir, if in the exam they'll ask to draw a diagram for a compound, then how?
Yeah, you can. It depends, no, because how they are going to bond together. Suppose here, if
So
I
it's
say,
like in the school we did some one sodium atom and then there are two small atoms joining.
correct. Suppose if I'm saying that this particular atom, this is say sodium atom, and suppose if I'm going to show you like this, let us suppose that this is what is shown over here is oxygen atom. Draw the structure in which a sodium atom has combined with oxygen atom. First of all, for this we will have to again get the electronic configuration. For that you will have to look into the periodic table. Okay. Now the periodic table that is there, it will be given to you in every question paper. This is your periodic table. Okay. Now sodium is combining with oxygen. Sodium is over here. Look at the atomic number 11. That is the number of protons. So over here the electronic configuration of sodium, because here Na is having 11 protons, so its electronic configuration is going to be 2, 8, 1. In the first orbit maximum 2, in the second orbit maximum 8, in the last orbit there will
So,
be 1 electron. Yes. Yeah, ask me your question. Same way we will get the electronic configuration of oxygen. Oxygen is over here. Okay, its atomic number is 8. I'll zoom it in so I can show it to you. This is oxygen, its atomic number is 8. Okay, so there will be 8 protons. So the electronic configuration of oxygen is going to be 2 in the first orbit, total 8 protons are there. Second orbit will be containing 6 electrons. Now from the electronic configuration I am supposed to get the valency. Sodium will give away its 1 electron. So valency of sodium is going to be 1. Oxygen is going to take 2 electrons. So valency of oxygen is going to be 2. When it takes 2 electrons, it makes the octet state that it will be having 8 electrons in its outermost orbit. When it gets rid of this 1 electron, it will give away that 1 electron. Now this is going to become the last orbit. So it is going to have 8 electrons in its outermost orbit. That is, it is going to have its octet state. So now here we have obtained the valencies. Simply exchange the valencies. This one will come here, this 2 will come here. So formula of sodium oxide is Na2O. It means here there will be 2 atoms of sodium bonded with 1 atom of oxygen. Now here if this is the key, then how are you going to draw that diagram? Okay, there will be 2 atoms of sodium. Of course this is an ionic bond where there is transfer of electrons. Okay, this is how you are going to obtain the diagram. This kind of diagram of course is applicable for covalent compounds or covalent bonds. Okay, here oxygen atom is in the middle, that is bonded with 2 sodium atoms. This will be the diagram. We will move on to the next question. Question number 4. The table describes the structures of 4 particles. Okay. The particles are given over here. Oxygen is there. There is no charge over here. I'm going to show you that with zoom in. You can see here this oxygen is not carrying any charge. It means here the number of protons and electrons are equal. Okay, the number of protons, neutrons and electrons are given over here 888. Here in the second case there is O2 minus. It means here this is a negative ion. It means it is going to have more number of electrons than protons. It is 2 minus. It means that this particular ion is going to have 2 more electrons than protons. It means here there are 8 protons, so there will be 10 electrons. So obviously X over here is 10. Okay, there are 2 options for X where 10 is there. The second part, the third of these species, sodium is there. There is no charge over here. Again, here the number of protons and electrons will be equal. That is obviously that is there. Okay, so we have to see what this Y is going to be. Na plus is there. So therefore here there is 1 electron less because it is having positive charge. So here the number of electrons for Z will be 10. Okay. So Z over here 10 is this. So automatically this Y, that is the number of neutrons, over here is going to become 12. So the correct option over here is going to be C. Okay. There are 10 electrons because here there will be 2 electrons more than the number of protons. Okay. For Z, it is Na plus. There will be 1 electron less than a proton. This is number of protons given. So 1 electron has to be less. This is number of electrons. So the number of electrons over here is going to be 10. Okay. There is only these two things that are matching. So the correct option over here is C. If anyone has any more questions, they can ask me.
So,
Yes.
so what about Y then?
Why? So that you will have to see, no? Because you see, when this part is given, suppose I'm searching for X, what is this number X? Okay, over here, two more electrons are there. It means this has to be 10. It means the only C and D options are correct. Okay, only these two options are correct. It means then why both of these are 12 only. So either it has to be this or it has to be this. Okay, either it has to be this or it has to be this. Any one of these. So over here, okay, Z which is there is going to have 10 electrons, and over here 10 electrons will be less from here because it is having one electron less because this is Na plus.
Sir, I have a question.
Yes, tell me, ask me your question.
So, that H2O is water, no? So the diagram is one hydrogen atom and two oxygen atoms with it in a diagram. That will be a covalent bond.
That will be a covalent bond definitely, because
That
if we are discussing covalent bond, of course that is not there right now for the test. But still, I'll
it's
explain you
not there,
quickly.
no?
Covalent bond, as you said, it's not there
So
for the test.
if it is not there, then it's fine.
Okay, fine. We'll do covalent bonding later because for your test that is not going to be asked at the moment.
So till what time you are taking?
We'll see that later. Question number 5. Which two elements react to form an ionic compound? Okay, now in case of ionic compounds, there has to be transfer of electrons. It means one atom is going to give it a certain number of electrons, other atom is going to accept certain number of electrons. Okay, there is no question, there is no possibility for X because here the orbit is completely filled. It is an inert gas, so it is not going to react at all. If you look at these atom W, it's having 4 electrons. It is in the middle, either. Okay, because to make octet state or duplet state, either it has to accept 4 electrons, which is difficult, or if it can give away these 4 electrons, then 2 electrons will remain in the first orbit. That is also what seems difficult. Instead of that, what can happen? This 1 electron can be transferred from here to here, because here 1 electron is there, only 1 electron is there in the outermost orbit, so it can give away this 1 electron and make octet state by having 8 electrons in this orbit. If this atom gains 1 electron, in that case it can acquire the octet state. So 1 electron can be transferred from Y to Z. So transfer of electrons, so Y and Z will be forming an ionic compound. Yes, you can ask me your any other further questions. Just 1 second. So no questions. Okay, we'll move on to the next part. The diagram shows the part of the periodic table. Okay, these are the elements that are located A, B, C, D like this. Which element is correctly matched with its electronic structure? That is electronic configuration. Now this what you can see over here is group 1. It should always have one electron in its outermost shell. Okay, you can see for A, it's having one electron in its outermost shell. Therefore, this is the correct option. Now we'll look at other things B, C and D. What is wrong over there? Look for what is there for B. Okay, the electronic configuration given over here is 2, 4. Okay, if I'm looking at...
So,
Yes.
sir, A will be wrong. So the electronic configuration will be 2, 1. C1 is right.
Wait, I'll come to it. I'll come to it. Okay. Just check this. Okay, because here the period also we'll have to see. Yes, of course. Okay, this is the first period. This is the second period. It means this should have only 2 orbits. Here there are 3 orbits. Okay, so this is not going to be the correct option. We'll look for what is there in other things for B. Okay, the electronic configuration given for B is 2, 4. If you look at the groups over here, this is the first group, this is the second group, this is the third group, this is the fourth group, and this is the fifth group. Okay, now B falls in the fifth group. It means it must have 5 electrons in its outermost orbit. So this is incorrect. Let's look at part C. Okay, its electronic configuration given is 282. Now see, this is your first group, this is your second group. Okay, it is having 2 electrons in its outermost orbit. And how many shells or how many orbits are there? This is your first period, so there will be only 1 shell or 1 orbit. This is your second period. It will have 2 shells or 2 orbits. This is your third period. It will have 3 shells or 3 orbits. So you can see over here there are 3 shells. Okay, so part C is the correct part. Not only the group number you have to see, you also have to see that how many periods it is having and it is placed in which period. Okay, so C is the correct option. For D, if you look at 2, 8, of course its group number is correct. This is group number 8. But then if you look at the number of shells, okay, for D, this is your first shell, this is your second shell, this is your third shell. So it must have 3 shells. So actually its electronic configuration will be 288 if it has to be located over here. Yes, any other questions apart from this? Yes, we can move ahead. Question number 7. In the diagram, circles of different sizes represent atoms of different elements. Which diagram represents hydrogen chloride gas? Okay. Now for that we must know the electronic configurations. Of course it's a covalent compound. Okay, hydrogen, the electronic configuration is 1 from the periodic table. And Cl is having electronic configuration 287. This will share 1 electron, this will share one of its electrons to make octet state. And both will have valency 1, 1. If you exchange these valencies, the formula of hydrogen chloride is going to become HCl. So there will be 1 atom of hydrogen, there will be 1 atom of chlorine. Okay. So obviously over here, where one atom of hydrogen and one atom of combine is observed over here. Yes, anyone can guess which one of these is going to be
A.
correct. It is A, where one atom is of hydrogen and other atom is of chlorine. Here the atoms are separated, so it cannot be. Here also, okay, there are two atoms combined together. That is not possible. This can be an example of H2O. Okay, here also single atom is there and these two atoms are also there. Okay. Question number 8. The diagram shows an atom. Okay. Now here the nucleus is given. There in the first orbit there are 2 electrons. In the second orbit also there are 2 electrons in the second shell. Okay. What is the proton number and neutron number of the atom?
So C.
Okay, because here there are 4 electrons, so proton number has to be 4. Okay. Now you cannot have neutron number 9 with 4 protons. Okay. So it has to be A. Okay. For proton number 5, you need 5 protons. And here they've said it is atom, it's not an ion. So it should have, because it's having 4 electrons, it should have 4 protons. Okay. So the option over here is going to be A. Okay. If you have any questions, you can ask me. Yes, we can go ahead to the next question. Question number 9. The nucleon number and proton number of the lithium atom are shown by the symbol Li37. This 3 is representing the atomic number. That's the subscript. This 7 is representing the atomic mass number. That is the superscript. That is the sum of protons and neutrons. And this is only the number of protons, 3. What is the correct symbol for the lithium ion in lithium chloride? Now lithium chloride is there, therefore first of all you should know the electronic configuration. There are 3 protons, so there will be 3 electrons. What will be the electronic configuration of lithium? It will be first orbit 2 and second orbit 1. Okay. It means it's going to give away this 1 electron, the lithium atom. Whenever it gives away 1 electron, it's always going to form a positive ion that will be equal to the number of electrons given away. As it is going to give away 1 electron over here, it is going to give away 1 electron, therefore it is going to be single positively charged because only 1 electron is lost. Okay. And of course it's not going to affect the number of protons or neutrons, so the correct option over here is going to be C. This is also single positive, but number of protons and electrons are the number of protons and neutrons are not going to change, therefore this will be wrong. Of course this is forming negative ion, which is not possible in case of lithium. question number 10. Element X has a nucleon, that is mass number of 19, and proton number of 9, that is atomic number is 9. To which group in the periodic table does it belong? Okay, now straight away when the atomic number is given, from that you just straight away get the electronic configuration. This atomic number is 9, put 2 electrons in the first orbit. How many more electrons are remaining out of 9? 2 are gone in the first orbit. So 7 electrons are there in the second orbit. Always from the electronic configuration, whatever is the number of electrons in the outermost orbit, that is equal to its group number. So therefore its group number will be 7. Because there are 7 electrons in the outermost orbit. I'm just going to discuss a few more examples of these kinds.
So can you explain the sum again?
Yeah. Okay, just look at this. Element X has the nucleon, that is mass number of 19, and proton number, that is atomic number, is 9. To which group in the periodic table does it belong? Okay, always whenever you want the group number, okay, group number is required, so always get its electronic configuration. When we want its electronic configuration, always look at the proton number, that is atomic number. Here the atomic number is how much? 9.
9.
Okay, so start filling up this. So 9 protons, it means 9 electrons. So start filling up the orbits. First orbit can have maximum of 2 electrons. Out of 9 electrons, you have already put 2 electrons in the first orbit. So how many more electrons are remaining?
7.
7 electrons. Those 7 electrons will come in the second orbit. As I've said earlier, number of electrons in the outermost orbit, that is always going to be equal to the group number.
Okay.
So because 7 electrons are there in the outermost orbit, its group number is going to be 7. Okay? So
Yeah.
this is going to be the correct option. Next question. The table shows the structure of different atoms and ions. Okay, so all these data is given: proton number, nucleon number, number of protons, number of neutrons. Certain letters are missing over here. Okay, so that is W, X, Y, Z. And number of electrons are also given over here. Okay, so we are going to identify over here what these numbers are going to be, and then we are going to choose the correct option from here. Okay, now in the first case, I want number of neutrons, which is W. Okay, always nucleon number, it is equal to the sum of protons and neutrons. Nucleon number is 24. It means 12 protons plus W neutrons, that is equal to 24. I repeat the last part. Okay, when I want number of neutrons, and here nucleon number is given. Nucleon number is the sum of protons and neutrons. So 12 over here, that is which is this part. W over here, which is this part. This is equal to the nucleon number, which is 24. So from this, I'm going to get the value of W as 12. Now again over here, there are C and D. There are two options. Okay. So I straight away have to reject A and B. We'll search for other numbers. Okay. Now see where X is. X is over here. That is number of protons. Okay. Now magnesium. Magnesium is here, the charge that is given over here is +2. The number of electrons over here is 10. Because it is having charge +2, it means there are 2 more protons. 10 electrons are there. There will be 2 more protons than this. Why? Because it is having charge +2. Because protons are positively charged. So 2 electrons are less, or in other words, I can say there are 2 more protons. Here 10 electrons are there, so the number of protons is going to be 10 plus 2 is going to have 12 protons. Okay, so X is going to be 12. Alright, second option also we have seen that X is also 12, so obviously the option over here is going to be D. Of course, you can also identify for numbers Y and Z. Yes, what is your question?
Sir, what is the difference between proton number and number of protons?
No difference. Proton number and number of protons is same.
Exactly. Then sir, why is it given like that?
So it's straight away this only. 12. Directly you will get it from here. X is 12. This W has to be 12 that I already showed with the previous part. Okay. We'll look for Y and Z also. Okay, Y is over here, that is number of neutrons. Now whenever number of neutrons and protons are involved, always look into the nucleon number. This is 9 over here. Nucleon number is 19. Always number of neutrons. This is equal to nucleon number minus proton number or number of protons.
दी दरवाजा आपको बंद कर.
Nucleon number is 19. Proton number or number of protons is 9. This is going to give me 10 neutrons. Okay, which you can see over here. There are 10 neutrons over here. Even Z also is the same thing. 9, 19 and number of electrons over here. Obviously, that is going to be equal to 10. Why it is going to be 10? Because here there is a negative charge. So therefore there has to be an extra electron more than a proton. So 9 protons are over here. It means because here F minus is there, it's going to have 1 more electron. So instead of 9, now you are going to have 10 electrons, which is Z over here, which is number of electrons. So the correct line that it matches is D. Okay, these kind of questions may take some more time, they may be time consuming. But then other questions that you may get will be much shorter. Straight away you can answer them. Okay. Yes, again over here we are supposed to get the formula of the covalent compound. Obviously you can see over here there is only 1 electron, so its valency is 1. This is nothing but hydrogen. Okay, hydrogen, if you see, it's having only 1 proton, so 1 electron. That is going to be the atom of hydrogen. Okay, so here the valency is 1. How will you get the valency of Y? Look at how many electrons are there only in the outermost shell. This is 1, 2, 3, 4 and 5. Okay, so I'm going to write down the electronic configuration of both. For X the electronic configuration is 1. Okay, over here the electronic configuration is 2, 5. 5 electrons in its outermost shell. It can share 3 more electrons, so its valency will be 3. So for X, the valency is 1. For Y, the valency is 3. Just exchange these valencies. This 3 will come over here, this 1 will come over here. So the formula is going to be X3Y. This is your option. I'm going to take a few more additional examples. Okay. I'm going to give you some electronic configurations. You have to give me and identify the group number and the period number. We are going to fill up this chart, this table for all of these elements.
Sir, we copy this.
So we have to copy.
Sir, do we have to copy this?
Yeah, you have to do it quickly. Has anybody has revised the class that I link I had sent yesterday? No one. Because you see, tomorrow the class is going to be offline class, so I will not be able to give much time. That's why I have been taking
But
longer.
So
tomorrow
right
what
now
time?
till what? So right now till what time are you taking?
Mostly up till 10:30 or 11. Because then you'll have school also tomorrow, so I can't keep too long session.
So tomorrow we have a holiday.
Tomorrow we have a holiday.
But tomorrow yet all these some of the things are going on over here still, and our class is also offline. Okay, till 2-3 days it is going to be like this. After that, then again we'll be able to keep very long sessions.
Okay.
Okay, let's begin with this table now. In order to identify the group number, okay, we just have to look at the number of electrons that are present in the outermost shell. Okay, if you want the group number, just look at how many electrons are there in the last or the outermost shell. There are 3 electrons in the outermost shell, so its group number will be 3. Now, if you want in which period it belongs to, or the period number if you want, you just have to count the number of shells. 1, 2, and 3. So it is in the 3rd period, or it is in period number 3. The third part of the table, you have to state whether it is going to be a metal or a non-metal. See, when an element is a metal, it is going to have either 1, 2, or 3 electrons in its outermost shell. Because it is having 3 electrons in its outermost shell, therefore it is going to be a metal.
Sir, can you repeat what you said for metals?
If it is having 1, 2, or 3 electrons in its outermost shell, then it is going to be a metal. If it's going to have 4, 5, 6, 7 electrons in its outermost shell, it will be a non-metal. If
So
it is
because
having,
it has to give electrons, no?
yeah, if it is having 1, 2, or 3 electrons, it is always going to give electrons. So those are going to be metals. Metals will have free electrons. Okay, and because since this is a metal, the last column is easy to answer. Of course, it is going to be a good conductor of electricity. We'll take the second element. Okay, the group number, it is having only 1 electron in its outermost shell. Group number is going to be 1. Also remember that this group number 1, that is the first group element. Okay, this is your group 1. All of these elements that are there, they all obviously will have only 1 electron in its outermost shell. And these metals, okay, if you remember what we have done in the past grade, these are known as alkali metals because they are alkaline in nature. Okay, this is group 1. All of them will have 1 electron in its outermost shell, that is lithium, sodium, potassium, rubidium, cesium, francium. And as you go down, its reactivity also increases with water or oxygen. It becomes more and more reactive. Okay, that was group number. Then period number, obviously, just count how many orbits or how many shells are there. 1, 2, 3, 4. So it is going to be in the 4th period. Again, whether it is going to be a metal or a non-metal, it's having only 1 electron in its outermost shell, therefore it is a metal. And since it is a metal, it will be a good conductor of electricity. Now we can finish this off quickly. There are 8 electrons in its outermost shell, so its group number is going to be 8, or it is there in the 8th group. Its period number, 2 shells or 2 orbits, so it will be there in the 2nd period. Metal or non-metal, obviously it's a non-metal. In specific, it is an inert gas or noble gas. And obviously it's not having any free electrons, therefore it's going to be a bad or a poor conductor of electricity. The next one, Number of electrons in the outermost shell, 7 electrons, so its group number is group 7. Period number, there are 2 shells or 2 orbits, so second period. 7 electrons in its outermost shell, 4, 5, 6, 7 electrons will be non-metals. If these many electrons are there in the outermost shell. And because it's a non-metal, it will again be a poor conductor of electricity. The last of these, 6 electrons in its outermost shell, group number is 6. 3 shells are there. Is there in the third period or period number is 3. 6 electrons in its outermost shell or orbit. Okay, so again this is going to be a non-metal. If it's a non-metal, the electrons are tightly bound, no free electrons, so they will be poor conductors of electricity. Yes, we'll go ahead with the next question. Again, this question is related to covalent bonding. And obviously here you can see the orbits. The orbits are overlapping, they are sharing the pair of electrons. Okay. These are the electrons that are shared. So the first option over here is the correct one. Okay, the hydrogen and fluorine share a pair of electrons. You can't share the number of protons because they are there in the nucleus. It's covalent bond. Again, this is covalent bond. Okay. Hydrogen is there, it doesn't contain any neutron. There will be only electrons and protons. That's what an hydrogen atom is. If you look over here, its atomic number is 1, so 1 proton. Atomic mass number is 1, so number of protons plus neutrons is also 1. So 1 proton plus 0 neutron, atomic mass number is 1. So no neutron is there, only 1 proton and 1 electron. So the correct option over here is going to be, it will be having only electrons and protons. Hydrogen is the only atom which does not have any neutron. Rest, all the elements in the periodic table have one or more neutrons. So this is the only atom, hydrogen, that's having a proton and an electron but no neutron. Question number 15. Which atom has 2 more electrons than an atom of a noble gas? So we'll have to work out the electronic configurations of each one of these. There should be 2 more electrons than the noble gas. Noble gas means either 8 electrons in the last orbit or 2 electrons in the last orbit. That's what an inert gas is. So aluminium, if you get the electronic configuration from the periodic table, atomic number is 13. So 283. This is having 3 more electrons than the inert gas. What is asked to us is 2 more electrons. Bromine, you can work this up from the periodic table. Its atomic number, that is number of protons or electrons, is 35. Start putting the electronic configuration. First orbit 2, second orbit 8, third orbit 18. Just add up. Okay. This is 28. Plus 7 is 35. This is not having 2 electrons more than inert gas. Calcium, atomic number is 20. So 2882. This all adds up to 20. This is having 2 more electrons more than inert gas. So the correct option over here is going to be C.
So,
Yeah.
so bromine, you wrote 18.7, but we can't write 18 now. You said that.
Yeah, there are certain such exceptions are there that you will do in IB chemistry. Okay, but at the moment you have to just go through at max the electronic configurations will be up till atomic number 20, that is up till calcium 2882. Now statements 1, 2 and 3 are about diamond and graphite. Okay, diamond, I want you to draw the structure of diamond.
Yashi, हाँ से look at ask the FM में देवम का वो देख देवम के कार्ड पे जा उसका अकाउंट नेम देख तो ऐसे क्यों हाँ समझाएगा जेबा रिया हाँ मुझे नींद आ रही है
मुझे भी। I'm hungry actually.
I want to have suppi. I'm getting cravings.
You always get.
अरे मुझे वो आज यशी को पूछ मैं उधर स्विमिंग गाला में किसी के पास सबवे का कुछ पेपर थिंगी था
हाँ वो 10th standard
Deona's captain name as Jeba.
we just said it Shreya
She's a tube light just like Yashvi.
even Yashvi
So funny. So funny.
हाँ so laugh now.
Ah, ah,
everybody is you but those subway sandwiches made me crave for it now I wanna have it
Right now.
right now I want to really have
I'm
what
bored.
else? What did you do after going home
Slept.
and
Nothing. What did you do? हाँ
कितना सोती है कितना सोती है
4 hours.
I'll see.
Yeah, okay. See here the structures of diamond and graphite. These structures you'll draw later. These are called macromolecular structures. The bonding in diamond is very strong, therefore it's having very high melting point of 4000 degrees Celsius. In case of graphite, the bonds are weak enough so the layers can slide over each other. So graphite is soft, therefore it is used in making pencil points. It can produce a black mark on paper. It is also used as lubricants. Diamond is a very hard material because these covalent bonds are very strong. These are the macromolecular structures of diamond and graphite. Okay, now we'll have a look into what these properties are going to be. Statements 1, 2 and 3 are about diamond and graphite. One more thing, these both contain carbon. These are known as allotropes. Okay, allotropes are substances that have different structures. The same element is there, their structure is different, because of that their properties are different. So diamond and graphite, both of them are allotropes of carbon. The element that is present in them is carbon only. So the first point over here, they are different solid forms of the same element. Yes, this is true. As I said, it contains carbon. Second, they conduct electricity. This is false. Diamond cannot conduct electricity. Graphite conducts electricity. So second statement is incorrect. Third statement is they have atoms that form 4 equally strong bonds. Okay, this is true for diamond, as I have shown you the structure, but it's not true for graphite. So which statement is correct? One only. If you have any questions, you can ask me. Yeah, done. Next part. An element S has the proton number 18. You can straight away look into the periodic table. Proton number 18. Which element is this? Okay. 18 is over here. This is Ar argon. Proton number 18 is over here. See what the question is. The next element in the periodic table is an element T. Next element. So obviously the next element from AR, from 18, the next element is going to be atomic number 19. Okay, which is going to be this element. Now what the question is. Okay, next element in the periodic table is an element T. Which statement is correct? Element T has one more electron in its outer shell than element S. One more electron in its outer shell. You can work out the electronic configuration or electronic structure of AR. It is going to be 288. So total becomes 18. Now it's saying that it's having one more electron in its outermost shell. It means they are saying that this element is going to have electronic structure 289. You know electronic structure of potassium is 2881. So first statement is false. Let's look at the second statement. Element T has one more electron shell than element S. Yes, this is true. Because in case of argon, it is 288. 3 shells are there. In case of potassium, it is 2881. So 4 shells are there. One more shell is more. One shell is more. Okay, so second statement is correct. Third statement also you can verify. Element T is in the same group of the periodic table as element S. This is false. You can see argon is over here 0 group, inert gases, while potassium is in group 1. So it cannot be in the same group. Last one. Element T is in the same period of the periodic table as S. This also you can see argon is in the third period, potassium is in the fourth period. Okay, so only one statement is correct, which is it has one more electron shell. So option B over here is the correct option. Next question. Question number 18. Which atom has twice as many neutrons as protons? We can work out the structure of each one of these. Okay. Hydrogen, that is, the structure is shown over here. This number, the superscript is number of protons, so it is having one proton. This is the atomic mass number, sum of protons and neutrons, that is also one only. So 1 proton plus 0 neutron, so no neutron is there. Only 1 electron will be over here. This is what is drawn for A. Now for B. Okay, obviously it's hydrogen. This is giving you the number of protons, so 1 proton. This is giving you the atomic mass number, that is sum of protons and neutrons. So 1 proton plus 1 neutron will give me 2. So here there is 1 proton and 1 neutron. Neutron doesn't have any charge, I am representing it as 1, 0. 1 and 0. And of course that 1 electron also will be there. Now the diagram for C. Again this is hydrogen. Atomic number is 1, so 1 proton. Atomic mass number is 3. That is sum of protons and neutrons. 1 proton is already there, so number of neutrons will be 3 minus 1. So 2 neutrons over here. And of course there will be only 1 electron equal to number of protons. Last atom is of helium. Two protons are over here. Number of neutrons will be 4 minus 2. So 2 neutrons. And of course, number of protons equal to number of electrons. So 2 electrons. I'll revert back to the question. The atom has twice as many neutrons as protons. The number of neutrons is double the number of protons. Okay, you can see here there are 2 neutrons, here there is 1 proton. So the correct option over here is going to be this. Any questions? Let's take up the next question. Which change to an atom occurs when it forms a positive ion? Okay, remember when there is a positive ion, it means it's having one or more positive charges. And positive charge is carried by protons, so number of proton will be more, number of electrons will be less. And only electrons can be given or taken. So positive charge will be the one when the electrons are lost. So the correct option over here is it loses electrons. You cannot gain or lose proton, that is not possible. If it gains electrons, it is gaining negative charge, then it is going to become a negative ion. If it is losing an electron, it is losing negative charge. It means when it loses negative charge, it becomes positively charged, that is positive ion. Okay. So positive ion will be the one which is formed by loss of electron, where the number of electrons will become less than the number of protons. The next question. Which numbers are added together to give the nucleon number of an ion? This is a straight definition, number of protons plus neutrons. Okay. Number of protons plus neutrons will give you nucleon number. Nucleon number simply means that they are present inside the nucleus, which is sum of protons plus neutrons because they are present inside the nucleus. This is also the definition of nucleon number. It is equal to the sum of number of protons and neutrons.
Sir, how many more questions you are taking?
I think so. This will be the last one.
So tomorrow you will try to take.
Tomorrow, otherwise you can do one thing. When I'm going at Yashvi's place at 6:15, you can come online if you are free.
Sir. So,
Correct. So I'll
so
take
we'll see
online.
that.
Correct. So you can come online over there. I'll take the class at her place, and you come online. No problem. Okay.
Fine, sir.
Yeah. Now the electronic configuration of an ion is 288. What this ion? What could this ion be? Let's work out the electronic configuration of both of these ions. From that we'll come to know whether it is correct or not. So sulfur, first of all, we'll look where this element is in the periodic table, and we'll work out the electronic configuration of S2 minus, because here this is 2 negative ion, 2 minus ion. So look where sulfur is in the periodic table. Sulfur is over here. Its atomic number is 16. Okay, this is where sulfur is. Atomic number is 16. It means its electronic configuration will be 286. That's the electronic configuration of sulfur. When it is going to become S2 minus, it means it has gained 2 electrons. Because here 2 negative minus 2 charge is there, 2 extra electrons are there. This is possible when it accepts 2 electrons. So then its electronic configuration of S2 minus is going to become 288. So this thing is applicable, yes, for S2 minus. We'll find out what is the electronic configuration of Ca2 plus. Calcium, if you look it into the periodic table, calcium is over here. Its atomic number is 20. Okay. So calcium is there. Atomic number is 20. Its electronic configuration will be 2882. This all will add up to 20. When it is becoming Ca2 plus, it's positive ion. This is possible when it loses these two electrons. So its electronic configuration of Ca2 plus is also going to be 288. So S2 minus is having electronic configuration 288. Ca2 plus is having electronic configuration 288. Just look at the first option. 288 is there for S2 minus also and Ca2 plus also. So this is your correct option. Okay, I'm going to send you, upload this class and send it to you.